everybody. Good morning, good afternoon, good evening, wherever you are. I appreciate everyone joining me today. My name is Mike Grove. I am founder and SVP of engineering at Stardog. I am the original architect of our platform, and I've worked in the graph analytics AI space for the entirety of my 20-year career, getting my start at the University of Maryland in a first of its kind research lab on semantic graphs, which is kind of the heart of knowledge graph. And that's what we're here today to talk about and build. So I just want to do a course overview. We've only got 90 minutes today and a lot of stuff to cover. I'm hoping a lot of this is hands-on for all of you. It will be hands-on for me. You'll be watching me do this, but I kind of put everything together hoping that everyone could follow along. So I'm really hoping a lot of you do that. It's a great way to learn something. Overall today, what we're going to do is we're going to spend some time going back and forth between slides and doing. We're going to put most of our focus on the doing part. We're going to talk briefly about why knowledge graphs are so important, why I'm personally so excited about them. We'll learn the basics of what knowledge graphs are, how they're constructed. We'll spend a little bit of time navigating a customer 360 knowledge graph. But the bulk of our time, we're actually going to try and rebuild it, or at least a good portion of that customer 360 knowledge graph. We've only got 90 minutes. But in the course of that time, we'll learn some data modeling. In fact, I wager to say you will learn everything you need to know about data modeling. We'll map some enterprise data, and we'll use an inference engine, which is kind of AI, to find new insight and derive new relationships in our knowledge graph. So if you want to follow along today, I'm going to go ahead and drop a couple links here into the chat. I know people can't ask questions out loud, so it'll be tricky to interrupt me, but do your best. Use the Q&A function, put stuff in chat. I have another window over here where I'm able to keep an eye on this stuff so we can get as close to interactivity today as possible. Playing along is simple, cloud.stardog.com. Start account is free. The easiest way to get started learning knowledge graphs, is where we're going to spend a lot of our time today in the Stardog. So go ahead, while I'm chatting here for the first couple minutes, if you haven't already gotten yourself a Stardog account, go ahead and do that. If you're planning on following along with every single detail today, the raw data, you're going to want to grab that. It's just a couple of CSV files. That's what we're going to work with. That's all you'll need. If you just want to listen and maybe follow along and click around with some of what we're doing, final product here, link is also in the chat, so share a link to Stardog. You can go ahead and see what we're going to build. I'll start there, and then we'll work back up to that knowledge graph, and that'll be there for you to take a look at later on as well. So just to recap what we'll be looking at in Stardog, I'll explain the tools a little bit more, but in case any of you start exploring before we get there, we're going to be spending the majority of our non-slides time in the Stardog user interface, focused primarily in Stardog Explorer and Designer, which, as their name suggests, are for looking at and for building knowledge graphs. We'll spend a little bit of time in the Cloud UX. It's got a lot of great learning resources, part of why it's such a great place to learn how to use knowledge graphs. And then you could probably guess which one this is, Stardog Studio. It's our IDE for power users. So obviously it's the one with the dark mode here, kind of hidden in the background. We're not going to get into Studio, but it's a really powerful tool for technical folks to write, debug, profile queries, administer Stardog platform itself. So something that we won't get into today, but if you become a Stardog user, you will come to love Studio. It's a great little tool. So we're going to jump into kind of the preamble, some of why knowledge graph before we jump into building them. So this is a great time. If you haven't gotten your Stardog account, go ahead and do that while we do this intro. So let's get started. Knowledge graphs and graphs in general are all about connections and connectivity. It's kind of the whole point. And that's really what organizations need when trying to leverage data. I'm sure everyone's, especially with this audience, all data professionals, acutely aware of the challenges organizations face trying to use data. And fundamentally, it all comes down to the fact that data mostly is disconnected in an enterprise. we've done some large-scale collection efforts to try and make a single large source of data that can answer a bunch of questions. But fundamentally, when you think about it, if you have just one data set, some data about a customer or customers, you can answer questions like, what's Mike's email and what's Mike's name? But as you build it out, as you make more connections, you connect that customer data to some rewards information. You connect it to social activity, support history. You connect it to purchase history. Start building those connections. You have a much denser network that you can take advantage of, and you can answer more sophisticated questions. You know, did Mike have any negative social posts after any recent transactions? Kind of thing you can't ask when you have just one source of information, where you have finite bounds to the data you're querying. And that's really what knowledge graphs are all about, bringing together that connectedness and connectivity to our data. But connectivity and connectedness isn't only for our data. That's kind of the micro scale. For individual use cases, for individual problems, we need to assemble the right data, put it in the hands of the right person at the right time. But as an organization, we need to kind of be empowered. We need to have the systems to be able to do this. And the connectivity at the lower level that lets us use data more effectively kind of bubbles up to the macro level of the enterprise itself. Analytics, governance, storage. 3 key parts of data management that companies do already. We're pretty good at it, but they tend to do these in isolation. Each of these activities is much better off when done connected to each other. Again, a lot of data professionals here, you're probably squarely in that analytics part of the life cycle here. So you know that there's not exactly a great catalog of all the data that's in storage. And some catalogs only catalog a particular part of the storage landscape in the enterprise. So all this disconnection that we see at the lower levels comes up to the top of the enterprise. But when we start using enterprise knowledge graph and kind of this principle of connectivity, the micro level and the macro level, we start bringing together a whole connected enterprise. And that's really how you can start supercharging your efforts when using data. The nice thing about this approach, though, is it doesn't end up as a boil the ocean kind of effort. It's what people tend to think of when they think of big data initiatives, MDM, data lakes. Like those were all very heavyweight. Knowledge graphs are a much more lightweight approach. They use data where it sits. It's much more freeing and enabling for data citizens. There's one place to go to look for data. You create this knowledge graph, this semantic layer. You may have heard of data fabric or data mesh. When you read the fine print, you see that knowledge graph is the most critical component of those architectural patterns. So everything kind of comes down to knowledge graphs and connectivity. And the central idea of harmonizing data and metadata, bringing it together in this single cohesive whole, and powering your enterprise the same way it's already been powered through all the same apps and technology and approaches. So you don't have to learn anything new or change how the enterprise operates to begin to take advantage of this approach. Knowledge graphs work based on 3 fundamental principles. And we'll spend a lot of time talking about the second and third today, but the first is virtualization, and it's arguably the most important. Knowledge graphs as a pattern, as a solution, need to reflect the reality of the enterprise data environment. That data is everywhere. It's moving at every speed. It's in every format. It's all across my organization. The rise of cloud and multi-cloud means that data is now spread all over the internet. It can't be held up waiting for data to get moved into a central location. I can't get held up waiting for a new ops team to be able to stand up new infrastructure. The world moves too fast. You have to be able to address data where it is. The virtualization is a key pillar for knowledge graph. But once you've brought all that data together into kind of a single virtual place, made all those connections, you overlay it with semantics. That's how you get this semantic graph or semantic layer. But the cool thing here is that there's not one semantic layer, there's not one model to represent the data, there can be many. And that key flexible point is how you can really be able to transform how organizations think about using data when you can change it on the fly, when you can have different ways of looking at the same bit of information. What exactly does that mean? Quick example. If I'm a customer of a bank, sales may look at me one way and say, hey, Mike's a great customer because we can sell Mike lots of things. Well, that's just based on the data they know about me. Finance may look at that same data and say, well, Mike costs us money because we can't lose this data, so we don't like Mike. Same data, two different points of view, two different models. This is what semantic graph is all about, providing that flexibility. And the last thing is inference. AI, understanding what your data means, taking advantage of the fact that you've merged together data and metadata, and being able to create a more connected whole. Connections are key. We've already talked about that. So the inference engine is built into the platform to provide that deeper, richer connectivity in your graph. And we'll see exactly how that works in a little bit. So that's kind of a whirlwind tour of why knowledge graphs. As Data Science Connect, I know not everyone has maybe a graph background, so just a few points about graphs before we start looking at knowledge graphs kind of in practice. So graph. Many of you are probably familiar with these. Certainly graphs and graph databases, graph technology is popular these days, but it may bring back memories from high school. Circles and lines, nodes and edges, things that are connected to other things. Graph databases are technology for storing these graphs. But where simple graphs and simple graph databases differ from semantic graphs is semantic graphs combine data and metadata. That two things in a graph are connected is important. There's a lot of graph algorithms that leverage precisely that fact, like PageRank. But that connection means something. That the connection has actual business relevance to a particular use case. And you need to be able to represent that as part of the graph. So that's what we mean when we say combining data and metadata. And this is done in a way, these semantic graphs are machine understandable. They're easily fed to machines. The LLMs, AI, our machine overlords will thank us for making our data more understandable by them and makes it easier for us down the road, because ultimately that's where all this data is going. We're going to use some machine to help us process it and understand it at scale. In semantic graphs, there are edges. One word you'll hear for them are triples. The idea is that it's kind of a three-part thing: node, edge, node, subject, predicate, object. Tom Hanks acted in Toy Story. It should sound like a sentence. That was the point. That's what we were after when we put this together. This is sometimes called a triple, but it's just an edge in the graph. So if you hear me say triple, this is just what I'm talking about. If you hear other people talk about triples in graphs and in context of semantic graphs, they just mean edges. If you've heard about graph databases, particularly if you've come from a labeled property graph background or have any familiarity with them, you've probably heard about edge properties. Knowledge graphs support them, Stardog supports them. They're typically used as displayed here to show the temporal aspect of a relationship. Sadly, as clearly illustrated here, I started attending college last century. So I'm representing that with edge properties. The actual way that this is done in practice at scale in production is with what's called a qualified relationship. So you won't hear me talk any more about edge properties. You won't see them anywhere really in any of Stardog's tools or our documentation. We do support them, as I said, but they're cute. They're for prototyping and whiteboards. Qualified relationships is ultimately where you end up. So that's where we'll be talking about how you would model this when we get there. So I have definitely rambled for long enough. So what we want to do now is jump into Stardog Explorer, which is what the name suggests, a place to explore your knowledge graph. So I would explain what it is, but I think it's easier just to show everyone. So what I'm going to do is I'm just going to hop on over to Stardog Cloud just so everyone can see Cloud, and I'm already logged in, so it took me right to my endpoint here so I can see my three applications: Explorer, Designer, and Studio. So I can get to any of these apps, and for any of my endpoints, I have a bunch of different ones here. This mic test is my current one that I'll use later on today, but I want to use the same link that you guys are using. So forgive me, I'm just going to jump back to the slides here and come to this demo. We'll zoom out of the way. always conveniently in the way. And now we're in Stardog Explorer. We can see our data model. For this example, I mentioned it was Customer 360, so you see the things that you'd expect from a Customer 360 data set. Customers, orders, products, purchases, credit cards, addresses, product categories. So very simple kind of canonical example that we can see here. But we're looking at the data model here in Explorer. Explorer does a lot of different things that I'll just kind of briefly tour. The controls for what we see here that you may need. Settings is where we'll spend a little bit of time today. When we turn on the inference engine, we'll click it here. You can select different graphs, different models. So this is what I was talking about before. Any graph can use any model to view it. So that's all done there in the settings. And then for Explorer, really, it's very nice to explore the metadata, but you want to explore the data. So let's see what that would look like. I have my product categories here, and I can go ahead, expand, and see any given product category. Let me just pick a particular one, electronics. So here I've already gone metadata, the data. My mouse is a little sensitive there. Extreme zoom in. Now I can see all products that are in that category. I need one of those products. I can pull it out and open it up, continue exploring the knowledge graph. Here are the orders associated with that product. I'm not going to attempt to pronounce that vendor, but it's got a vendor and a unit price that's inconveniently hidden here behind the legend. Or a habit of doing that when I'm trying to show things, but it's a very expensive USB stick. It's $600, you can see here. This is actually a hyperlink list. This is the graph itself, so I can go jump into this vendor. I can see all the other things they make for that product. I can continue stepping through this handing block here, all of the purchases that were made for those products. This is what I'm talking about when I'm talking about connectivity. Everything is connected. Everywhere I want to go in my knowledge graph is just a click away. But just clicking around is nice for this. It's nice for a demo. But sometimes you actually want to do a little more directed looking for things. So you can do semantic search here in Studio. So I can search for TV and find the 7 products that match. Immediately I can select a specific type of thing that I'm looking for and narrow down my results to only that category. But search isn't always enough either. Sometimes I want to look for something very specifically, so I can jump into Query Builder. So we were looking at the electronics department before, so maybe we want to find customers who have made purchases in electronics. I want to make that query. I don't need to know anything about the graph that's under the hood, what technology it uses, anything about query languages. I don't even really need to know how this data model is constructed. I know I'm looking for customers, and this is a model-driven interface. So I'm only going to be shown things that make sense for customer, and names and emails and social security numbers. Hopefully that's secured, which it is, but we won't get into that today. And all the different relationships it has with other things in its world. So I want to see customers who have made purchases. Their orders. Orders are for products, and those products can be in particular departments or categories, excuse me. Change the nomenclature right before this. I'll keep screwing it up. Let's go ahead and pick electronics. So I can see all the customers who have made purchases in electronics. Very simple, easy query for me to execute against my knowledge graph here. I see 100 and I hit my limit. I can go ahead and further constrain my query, and it will help guide me to what makes the most sense. It knows price is a numeric value, so I only get numeric operators. Synthetic data sets, so excuse the absurdity of the price, but there's a lot of big spenders in this data set, so I have to look for people over 10,000. And we find the 79 customers who have made quite large purchases in electronics in our fictitious e-commerce store here. But just getting the list of customers is nice. I can see it here kind of as a graph or as a list. But if I want to understand a bit more about how this came together, I'm going to toggle on the expand graph results option, jump back to the results of that query. And It's 79 customers, so we've zoomed out a fair bit, but you can see kind of the overall structure or provenance of the answer. So category, that's electronics there right in the middle. You can see all the different customers. Those are the yellow circles around the outside. And then in between are the orders and the products. So all the orders they made and each of the different products that they purchased in those orders for more than $10,000. So one of which was a mouse pad. That's got to be the most expensive mouse pad ever. I wonder what poor soul made that purchase. Dory Gregerson. I hope they really love that mouse pad. It's very expensive. So this is how people navigate their knowledge graph with Explorer. But as we saw at the beginning, it starts with the data model, how everything comes together, the foundation for those connections. So let's jump back over and talk about how to do data modeling. This is also a good natural break for me to remind everyone. Q&A is open. I am attempting to watch. I got it open here right next to me. You can also put stuff in the Zoom chat as well. I will attempt to answer any and all questions as they come up. So data models. Data models describe our data in a particular way, typically for a particular use case. So it defines all the business concepts, all the terminology that we need to describe a particular domain. These data models can be used for any number of graphs, and you can have any number of models for a particular graph. They're very reusable. There's the point of this technology and that flexibility of having multiple models gives you different ways to slice and dice your data. The key part of these models are classes. Classes represent sets of individuals, so typically nouns. These are organized in a hierarchy. So they will often be concrete things like an artist or a band or a song, but they can be things that are more conceptual, as I've got here, a 60s era band. So you can not only say that the Beatles are a band, that's obvious, but you can infer that they are a 60s era band by the fact that they were active and had put out albums during the 60s. So what you could do is infer that they have that type. The Beatles are a kind of 60s era band. This is what the inference engine does. It uses the rule that says, hey, any band that released an album in the 60s is a 60s era band. So this is the idea of you can begin to use these classes not only to literally type things, the Beatles are a band, but to have kind of macros or meta concepts that begin to chunk off parts of your knowledge graph that might be interesting for a particular use case. So it's not just about saying that something is something. That John Lennon is a solo artist. You could say he's prolific because he's put out a particular amount of records. And then anyone who's met the same criteria will also be of the type prolific. I can see we have a question. Is Stardog built on top of Neo4j? We'll answer that live, and I will say, thankfully, no. Stardog is built from scratch. We came to graph databases and started building around the same time as Neo, but we were two very fundamentally different systems. Neo4j is a graph database. We talked about those before. They're very good for simple point use applications where you have a graph problem, you have a graph data set, and the graph is all in one place. Knowledge graphs are for data management, enterprise data management, solving data problems. That's not what graph databases are for. So Neo is a great graph tool. If you have a very simple graph problem, it could be a good choice for that. When you have data problems, data integration, data management, that's where knowledge graphs come into play. That's why you see the analysts talking about knowledge graphs and data fabric as fundamental parts of the connected enterprise. Next is classes, properties. The properties link individuals. So that's what gives classes those, gives those individuals their data. Properties come in two different types or flavors. Attributes, that's kind of the individual primitive values, strings, integers, floats, and then relationships, connecting individuals to other individuals. So Mike and Stardog would be two individuals, and we would be connected by the relationship work at. And my wife, she and I would be connected by the spousal relationship. And I have an attribute, it's my age, which will soon be 43, so a number. Properties can also be inverse, symmetric, or transitive. So those are some additional traits that you can apply. And they have the obvious definitions that you would expect. They can also be organized in a hierarchy. So you can have leader is a subtype of member. So all leaders are members. You have to be in the group to be a leader of it. So you're obviously necessarily a member as well. Classes and properties are associated with each other via what's called their domain. And properties can have a type defined by their range. These are the terms for these, but these are just suggestions. So it's a little bit, for anyone who's got programming experience, it's a bit more like a dynamically typed kind of situation than a strongly typed. You can use properties however you wish. That's part of the beauty of the schema flexibility of knowledge graphs. But sometimes that can be a pain. You don't want properties to be used out of place. So this isn't something we'll get into today, but it is an important aspect of a data model. So I do want to mention it briefly. Data validation. Data is not very useful if it's not correct. If you give the most advanced machine learning algorithm in the world incorrect data, it's going to give you wrong answers. Doesn't matter how sophisticated the algorithm is. Data validations, you can think of like unit tests for your data. They describe what your data should look like with respect to your data model. And you run them kind of like unit tests. If you have 100 of them, it'll tell you out of those 100 how many were violated. So then you can see, well, for those constraints, where's that invalid data? And you can work to improving your overall kind of data quality through the use of knowledge graph. Again, we won't get much into this today, but it's something I did want to touch on because it's an important aspect of data modeling. All right, so I mentioned earlier, I've done data modeling for my entire career. I've distilled down everything I think you need to know into a handful of slides. So we're going to go through that, and then we're going to jump into actually building a model. So modeling in a nutshell, I tried to fit it all into one slide, and it spills over a little into some others, but this is effectively all you need to know. Start with a couple key concepts. Get a small piece of paper, get a little notebook, write it down. These are the handful of things that are most important in my use case. A couple attributes, relationship in between. That's where you start. Then maybe also where you end. You don't need to have huge, complex, sophisticated data models to actually get a lot of value out of your data. And my advisor, when I was in college, he liked to say a little modeling goes a long way. I'm paraphrasing, but that was his intent. Overspecification will always hinder reuse. And so does the size. A data model of 100 concepts is absolutely enormous. Like a function, you kind of want to keep it all in one screen. So larger data models should be broken up. And as such, you should think about data models as composable, like Lego. Reusing them is absolutely essential. It's part of the amazing value you get from knowledge graphs, being able to piece together these data models in many different ways and get new and novel ways to slice and dice your data. The models, as we saw with Explorer, are like our entryway into the data. At a root level, they encode what the data means. So their terminology, their labels should reflect how we talk about the data. We don't want to be cute. We don't want to use acronyms. We don't want to use opaque identifiers. We should use clear, obvious naming so people understand when they're looking and explore what they're seeing. And the last thing here, data is invariant, modeling is flexible. Knowledge graphs, what was that first pillar? Virtualization. The data is somewhere else. You don't have access to the data. You can't change it. So it's a very different way of thinking about how you interact with data than perhaps you're used to, because you can't go, I don't like that data, and then just change it. You change your data model, and your data model will change what the data looks like to you. And you can just choose to ignore the old way of looking at the data, use the model that reformats it in a way to fit your liking. That's a bit of a a mindset change. But once you adapt that, you really begin to understand why knowledge graphs are so flexible and how you can be so productive so quickly. So I was talking about a little bit of modeling goes a long way, should be composable, small, put them together like Legos. So this is what that actually ends up looking like in practice. You're going to have the layer cake, as we called it, of data models. So at your root level, there we go, you're going to have core concepts. So person, business, address, things that mostly everyone will agree on the definitions. And then the specificity is going to increase as you go down to very concrete, very specific models. You can have a model that defines churn risk. You can have multiple different models that define different ways to think about churn risk. And you can apply them at the same time, one after the other, alternating to your knowledge graph to understand the different implications of the different ways to understand churn risk. Not changing data, you're just changing how you look at it. You're changing the lens with which you view the data. Think of these models like lenses. And you can see this is why all those models stay small. The specificity goes in those leaf nodes at the bottom, not at the top. You know, little pieces of specificity that you can put together in different ways to begin to get the behavior that you're after. So this is how you correctly create these models and assemble them within your organization. All right, so with that, that is Data Modeling 101. That is hopefully everything you will ever need to know about data modeling, modulo a few corner cases, but that'll get you most of the way there. So now we're going to go back to Stardog and we're going to put some of this into practice. We had Explorer here, and I'm just going to jump right on back to Cloud and into Stardog Designer. I'm going to create a new project. You guys probably don't have this many projects sitting around. You can see at the bottom my many attempts at practicing this, so hopefully this one goes smoothly. I'm going to create a new project in Designer. Project is what you use to create a knowledge graph. So first place I'm starting here is the model. So I'm in the model view. I'm going to create my basic data model for my knowledge graph. Hopefully, for those of you following along, you are here in Designer with me. You can get a Stardog Cloud free account. So be a free version of our platform. Be able to do this straight away, or you can just watch along and come back and do this later. Or again, you can see the final product like we were just browsing. But we're going to go ahead and use Designer to create our demo. Customer, we said it was customer 360, so you always start with customer and someone who made a purchase. That's cool. Our customers, and go ahead and give them some attributes. We're going to have a name. Those are strings. I'm doing email, so string, and a phone number. We just had a question. In the layering that you mentioned, does one model reference other models? Or do you switch models? Yes, you can absolutely just switch the models. So our tooling is set up such that you can just flip-flop the model. Close Explorer, but in that Explorer details, you can just select new one, see the same data with a different model, but you can have models build on top of each other and kind of import from the other model, just like you would with a library or a piece of code. A lot of those rules probably should sound like your common SDLC. Here's a slide that we'll go to that mentions this parallel. So a lot of the same practices and rules apply. And here's my customer. They've got a couple attributes, email, name, and phone. I can go ahead and create them. I'm going to create customers, and then customers make purchases, right? Just go ahead and create that class. And what else did we have in there? And products, and we have category like books. So here's my 3 to 5 concepts in my domain: products, categories, customers, and purchases. A couple attributes for customer, nothing else for anything. So let's go ahead and fill this out. I'm going to say customers, relationship from customer to purchase, and they made the purchase. There we go, so we can see that. Now we're going to add a relationship from the purchase to for product. It's from a purchase to a product, and products are in categories, right? And we've got customers, purchases, for products in categories. That's our rough data model. And we can go ahead and we can reuse the name property here from elsewhere. In fact, everything's probably got a name, so we can go ahead through and select name, but we know product's going to have MSRP or price. It's a float. And then purchases, we can go here. They will not have an MSRP. They will have sale price, also a float. They will have an integer. And we've got price and quantity on our purchase, which is for a product as a name and an SRP, and category which has a name. Purchases, let's add. We've got our handful of properties, handful of classes. That's a pretty basic data model. I think that's going to work for us. So I can see it here in Explorer. I can go ahead, here in Designer, or I can see it in Explorer. I can go ahead and publish over ESC2. Need any of those assets? I'm going to create a new model. No data to upload. Published my project. So now I can go back over to my server, come over to Stardog Explorer, ESC2, and visualize is what will show me the data model, and voila, I've got a data model. Pretty simple, pretty easy. Now there's no data in here. I can't do the trick of what I did before, right? Because we didn't add any data, but that got us to the point where we've got a data model. It's simple, but it's pretty effective. The next thing would be to do what's called mapping, bring data into the knowledge graph. So before we do that, I want to jump back over to some slides. We'll kind of wrap up modeling here, and then we will jump into mapping. So just to recap some of the things that we talked about for modeling, the data model lives with the data. And I think this will be more clear when we're in Designer bringing the data in, that modeling and mapping and data and metadata, it's all one single continuum. The knowledge graph contains all of them. There's no one right way to model. It's not like MDM where there's a single definition of customer. You can have any number of definitions of customer. They can all be contrary to each other. Nothing wrong with that. In fact, I absolutely encourage it because that's how you get the most value out of the knowledge graph. I mentioned this earlier. A lot of the rules, they're derived from SDLC best practices. So that's for a good reason. We've been doing this for a long time. You can start small, iterate quickly, do these things in 2-week chunks, and very quickly build up a very compelling foundational piece of enterprise data management infrastructure. All right, so let's now get into mapping. We got a question here before we do that. If I don't know all of my properties at the time of class creation, can I add them later without having to redo everything? Absolutely. You'll see some examples of that because I'm fairly certain I forgot several properties. So we'll see what that looks like in a few minutes. So building the enterprise knowledge graph. So you can see kind of here the lines in between our data at the bottom and the knowledge graph or the data model is represented by circles and lines at the top. Those little lines in between, those are created through the mapping process. And you can think of it as almost a one-to-one correspondence from a particular cell in a table in a relational database to a particular node in your knowledge graph. So cell in the RDBMS goes directly to your knowledge graph. So you're just drawing those correspondences. This is what mapping is doing. And mapping is not moving the data. It's just kind of, well, it's a map. It's saying, hey, the data is over there. That's where you go get it. So Stardog uses these mappings to access these systems when you send a query to the knowledge graph. So it'll turn around and turn it into whatever the source language is. Maybe SQL, could be REST calls to something like Mongo. But this is all happening in that mapping and virtualization layer. Let's look at kind of the mechanics of this, and I think this is really helpful because Designer looks like this. And I think it'll help you understand why Designer is designed the way it is by seeing how the mapping process comes to be. All right, so this is our relational schema. It's a slightly different use case, but going back to our previous example of a music data set, this is actually from one of our tutorial data sets. Artists, albums, tracks, songwriters. So this is what the shape of our data is relationally, how it's stored. That's what relational schemas tell us. They tell us how data is stored. Here we can see how that data is stored kind of cartoonishly in track, songwriter, album, and artist tables. So we're going to map. We're going to draw those correspondences now. So we say the artist table, it contains the concept artist, and the name column is where you get the name property value from. So you can see here, we're just drawing those little correspondences from the cell in the relational table to a node in the graph. And then we just reiterate on this. Wrong way. Next table, next columns, we're going to do albums. So there's albums, name to the name property, date to the date property. And then artist is a little tricky because it's a foreign key relationship, but we know how to create artists. So we're able to just leverage that, and that'll connect. We talked about connections. Connections are key. Those two tables into a single graph. And then we do this again. So we do it for tracks. So now we've got artists and albums, and we can fill up those albums now with the tracks. And we'll draw our correspondences, and we'll link things one by one. And then finally, we can have songwriter association table doing these relationships between songs and artists to denote who wrote what. And you can see our graph arises from this mapping process. But what's going on in Stardog is Stardog's not actually creating this graph. And this graph isn't copied over. I said there's no copies. All this kind of exists dynamically. Stardog knows this graph is there, but the data is stored in the relational system. So what you see in Explorer is this. What you see in Stardog Studio is this. What you would see in Tableau is this idealized graph. Stardog hides from you the fact that the data is stored in a relational system. We'll go get it from wherever it's needed. And this is the joy of the abstraction of the knowledge graph. You don't have to worry about those sorts of things. So let's actually go do this now that we've seen kind of what it looks like. I'm not going to do inferencing just yet. So we'll go back to Designer. So we can see here we're back in our project. And we're going to import a project resource. So for anyone who grabbed that GitHub repo, we're going to use those files now. And of course, I lost my handle to them. And DSC and cat. So the first thing I'll do is I will get an overview of my project resource. That's what Designer calls a thing containing data. That thing containing data could be a CSV. That's what we're using today because that's easy for a workshop like this. But it can, and often is, a remote data source, typically relational. But Mongo, Cassandra, Elasticsearch, they can all be part of your knowledge graph as well. Those sources, those are all found through integration with your data catalogs, Purview, Dataverse Unity, Calibra, whatever you have, Stardog's able to tap into it and give you choices about what that might look like. And I can, if we have time at the end, I'll show you what that looks like on a different server that's actually got a few data sources connected to it. But for now, we're going to stick with the workshop, and here's our department data set. All the different categories for all of our different products here. Go ahead and do this create and map option. We've already created our data model. I have a data source category, and I want to map it to the concept of category. Go ahead and say next. Created the mapping for me, and we've got an auto mapping utility in the background. It already figured out that the ID column was the primary identifier. That's correct. And it made the right association between the name attribute and the department name field in that table. That's also correct. Exactly what we wanted. So all I've got to do is select department name, and that's the label. And I could be done with this mapping, but there's two more fields in there, the description, and some categories have parents. So we want to do both of those things. And to whomever asked the question earlier, I forgot those. So let's see here, right in the mapping, I'm going to add stuff right to this concept. I'm going to add description. And that's a string. Boom, as you see, it shows up right away. And then I'm going to select description here. And I'm going to be done with this mapping. This next one's parent. That's a relationship. It's not an attribute. That mapping screen that we were just on is for all of the attributes of the class. Relationships will look a little different, but same kind of idea. First thing I need is the relationship. As category. From category to category. So relationships can be reflexive and they can point back to themselves. And then all I need to do is create one more mapping. I'm just going to drag that right to that edge. Creates a new mapping. Now, it guessed wrong. ID and this should have been parent. But that mapping is done. And you can see everything changes here as I've connected things into the knowledge graph. So these three concepts are still white. That means they are not yet connected. This relationship, this concept are connected to the knowledge graph. They've got something mapped in. So that means they're kind of connected and ready to go. So we can go ahead and now publish this again. So my server that I was working on, my knowledge graph server, that knowledge graph database, don't need the assets. I'm going to replace what was there and create the new data source. So I'm all done. That's published. I come back to Stardog Explorer and just refresh. The Stardog Explorer will keep a cache of some things. So you can see here's my parent category relationship. And now I see categories. I've got baby. And then if I look at details, I've got the name, the label, and the description. I want to find, make them all go away. Let's just get all the categories just so we can see that our has parent relationship did work. Beauty, has parent personal care. So you can see we got data in here. We have our data model. We extended it. We even created a relationship between individuals here. Beauty's parent has a parent category of personal care. That's really cool. So that's a good chunk of our knowledge graph. So let's go through and create mappings for the rest of these. The next thing we want to do is our product catalog here. So we're going to go through the same process again and select product catalog, this products file. We can see products, MSRP, these departments, those categories. It looks very similar. We're going to create and map again. Create and map to my product. Auto mapping again helps me out. Gets a couple of these right. Didn't get the name because there's product. Can't get them all, but it does help me with some of the work. And I do have a few other things. It's got description here. So we want again, I forgot it. But I don't have to add it this time. I can just use the existing one and associate with that. There, now products connected in, and I want to create this in category relationship. So it'll be exactly the same as last time. Select that source, add a new mapping. There we go. And that goes from ID to department. I will associate products in their categories. So now I've got these connected. Products, categories. Let's do our next one of purchases. Let's do customers first. That'll be a little bit easier. You can see all of our customer data here, right? Go through and say, yep, customer is what I'm mapping to. Phone, name, email, ID. Yep, we've got everything right. The auto mapping, so I don't really have to do anything other than set the label and approve all of these. I'm basically done. I don't know that I want to map the rest. There's a lot there and a limited amount of time. And that last source, purchases. We'll see here, this is kind of our most complicated one. We've got foreign keys to multiple different parts of our knowledge graph. I'm going to create and map this to purchases. The auto suggestion, is that correct? And you can use that ID for the label. It's good enough. Price, purchase date and date. Wasn't sure about it, but it did get it right. Quantity and quantity. So that's cool. I don't really have to do anything. If there's any other things here that I would want to add, I could go ahead, but that's good enough for me. So the machine took care of all the hard work. I just had to bring my data with me. And I'm going to just do these last couple relationships, made a purchase mapping, open that up. And that's going to go from purchases to the foreign key, customer ID. That's done. Now I'm going to do the same thing. See a question in the chat. I will get to it in a second and kind of see how this is going to these three different things here, where we map these three relationships. But this one's not blue yet because we didn't go in and fill it out. For product mapping. So product will be product ID. Now I have, it's like everything blue. Everything's all connected. All the things that I set out to build, I connected. I forgot a few things, but I was able to, along the way, kind of stitch them in as I went, which is really exciting. I didn't have to kind of break my flow. So I've got all this mapped out. I'm going to publish this, and then we're going to jump over to the question before we see the results. I'll replace my model, replace my old data, create new, accept all those defaults. I will go ahead and publish. Let's look at our question. Is it possible to start with a file and generate a class from that file rather than start from the model? Yeah, so we will actually suggest, so do it very, very quickly. Hopefully, anonymous attendee, you are watching. US locations here. So I didn't create the data model for this. Here's some address information. I'm going to create and map. I'm not going to select anything. I'm just going to say go ahead. Slightly different experience here. These are the suggested properties that are going to get created. A new class will get created. So I'm just going to accept all of this. You can see here, it created, and this concept's called US locations. It really should be address. And that's what these are. But city, state, ID, I may want to make states, not strings. I may want to make those things rather than strings. But for the most part, naming side, it got everything right. So it'll do modeling for you based on the structure of the file. We are also integrating with LLMs like everybody else. So the idea is you will say, hey, I need a customer 360 model. It should represent customers, products, purchases, and product categories. It's for an e-commerce retailer. And we'll spit out a data model pretty close to what we just made by hand. That took us about 15 minutes. An LLM will generate it in about 15 seconds. So we're definitely looking at ways we can supercharge and take advantage of what people are able to do. Make best use of human time and make best use of AI time as well. Let me go back over to Explorer now, and I'm just going to refresh so we can see the results. Now, I didn't publish the addresses, but we should see now all of our data. The categories, baby, and there's the products in the baby department, diapers, all of the purchases. For any of those purchases, there's Jamal, Jamal's other purchases, and we can keep on going, keep on following our nose. This is for door handles. Who else bought door handles? That's these. It's in the industrial department. So we've recreated a fair fraction of what we were doing earlier. It took us about 20 minutes start to finish to bring that all together. We use CSV files, but the experience is identical for a relational system. This is a very simple interface to use. We expect you to be able to move quickly. But as I showed, we've built a lot of automation, helping when you have a data model, so doing auto mapping for you. When you don't, making the model for you. As I said, we're integrating with LLMs to make this process go more smoothly and easily. Businesses move fast. Your data layer has to move fast as well. That is mapping modeling. Answered that question. All right, so back to our presentation. We're going to talk about inferencing. Inferencing is stated here, making the implicit explicit. So the idea that you can define something, some piece of business logic like a large purchase, to use our use case, is any purchase over $10,000. We saw that was kind of our big spender cutoff. So normally, if I need to find those people, I'm writing a program, I'm doing something external to my data set, and it's kind of locked away separate from my data, even though that is part of my representation of the data. So what inferencing lets you do is start moving some of that intelligence into that smart data layer. It becomes part of that metadata layer, merged with your data, it becomes part of the data itself. So this is a key fundamental part of knowledge graphs. I think it's a really cool feature. And let's just walk through what this looks like at a high level. But I do want to point out that these inferred relationships that the inference engine finds, they're never stored in your knowledge graph. They're computed as they're needed. The data exists elsewhere, right? It's in some Databricks data lake somewhere. That data can change out from under us from one query to the next. So we can't save these inferences. They're computed when they're needed, and they're computed across data sources. So you're able to find connections that exist logically based on your understanding of the data, but that you could have never have otherwise found because the data wasn't together until knowledge graph. That's the power of the inference engine. So we have our music example here. Very simple case of 2 songs and 3 people who participated in writing those songs. We're going to see what the inference engine can do in enriching this very modest knowledge graph. So the first thing we want to do is just, and I mentioned this, properties have traits. We want to say that there are 2 properties, writer and writer up, and they're inverses of each other. So immediately the knowledge graph will know these kind of inverse connections, going from Rolling the Deep to Adele and then back, the inverse relationship. And then we can connect nodes based on some of those. So we can use that inferred relationship writer of and say 2 people who wrote the same song are co-writers. So you can see very simple if-then style predicate logic. These are easy to write. This is the actual syntax that you would use. So there's no crazy tools. You don't need to be a wizard. This is very easy to put together. And that's what I want to do here. And this is really amazing because we've now connected 2 nodes that weren't originally connected. And this is the power of knowledge graphs. And this is why connections matter. We're making a connection that didn't exist. Everything else you could kind of get to, but Adele and Paul McCartney had no direct connections. We're going to use the inference engine to draw that connection through layering on top of these different rules, so that the different rules that the inference engine uses layer on top of each other, just like the models do. Use this really rich language to represent what your data means. And all those inferred relationships you can take advantage of. You can use them in SQL. You will see them in Explorer, which we'll see in a second. You can use them in Jupyter Notebooks. They are part of the knowledge graph like any other data. Except they're not in the knowledge graph, and this is a really cool thing. Explainable AI is well, it was a hot topic. I think LLMs just reignited that. They can be inscrutable at times. And one of the really cool things about Stardog's inference engine is its logical inference. So it's not statistical like machine learning. It is mathematically provable. So you can ask for those proofs. So let me just jump back one. There, jump back one. Paul McCartney and connected to Adele. If I see that in Explorer and I know how are they connected? They're separated by decades in time. How are they connected? There's no way that they could be. And the knowledge graph can tell me, using all that information that the inference engine was just kind of showing there, and say, for Paul McCartney to be connected to Adele, is for these reasons. Connected to is defined as transitive. And then all the different pieces of data that gave rise to it, including other inferred relationships, here highlighted in orange. So the inference engine isn't using just the data that's static and explicit. It's using other inferred relationships to derive more information. And that's a really powerful concept. And we can do it ourselves very easily. We're going to go ahead and jump into by going back to Designer. We'll be asking questions, so we're going to take a quick pause. Can class have mappings to multiple files and resources? Yes, absolutely. In fact, that's the expectation. There is zero chance that a concept like customer lives in one and only one place. So whether you have that in one designer project or multiple, that's up to you. But you can absolutely map the same concept to different places and have like the total set of customers arrives from fundamentally queries to Databricks, Mongo, and Cosmos. That's unbeknownst to me, the data scientist, because I'm just saying, hey, give me all customers who made purchases in electronics. Stardog's the one that figures out how to make the individual calls to those services and pull back the customer data based on those mappings that we create. Can EKG support building product recommendation engines? Yes and no. Because EKG is more about data and the connectivity, and then providing better fuel for the machine learning engine. So what it's really going to do is empower a better product recommendation engine by giving you more accurate, more complete, more timely data, more comprehensive data. So you're going to get better recommendations, but you're still going to use the same algorithms. There's no different algorithm that the knowledge graph unlocks. It unlocks better results through better data. And how is data security implemented? Would the result of a knowledge graph be different when different people have different access? Yes. So answer live and done. Yes, the answer to that is absolutely yes. So when you send a query, the query is happening kind of as an agent, and one agent may not see the same data as another. So different queries with different access levels return different results from the knowledge graph. The knowledge graph will work with the access controls at the source system. It also has its own access control, so you can lock down parts of the knowledge graph. Fundamentally, we saw social security numbers earlier. So you can say, hey, social security number is a sensitive property. No one can see it. So you may want to have it available for queries if you have the HR role, but for everyone else, it's X'd out. So you have a lot of different options on how data security is done within your knowledge graph. Okay, yeah, rules. We're going to create some rules. So first thing is, let's create the one that we've already talked about, a large purchase. Large purchase. So it should look very similar. This is based on the same interface as Query Builder and Explorer. That's by design. So we're looking for purchases. We already know how to use this interface because we used it in Explorer. Where the price, bill model driven, greater than $10,000. But I'm kind of stuck because I didn't define what a large purchase is. I don't have a placeholder for it, in a sense. Purchases. So I'm going to go ahead and add a new class. That's there, and I'm going to say it is a type of purchase. It's purchase as a parent. So it's a specialization of it. Back to my rules, which I have to start over, but fortunately it wasn't much. I'm going to say purchase price is greater than 10,000. Then I want to say that purchase is classified as a large purchase. And go ahead and save that with this one rule. And actually, let's just see what that looks like. And then we'll come back and we'll make some more rules. But I think it's kind of fun just to see the first thing work. And see, designer knows we've got rules. It's asking us if we want to publish those. Yep. Well, I guess we'll have that data. US locations. It doesn't trip me up. I didn't do that in my practices. Well, we'll find out. I'll go back over to Explorer. We'll refresh this window, go back to the model overview. We'll see our new class. Large purchase here. And you can see also address that we added that's just kind of floating off on its own. But large purchase is what we're interested in. So we want to go back to Query Builder and say we want to find all customers who made a large purchase. Cool. Graph, that's weird. No results. Why would that? You turn the inference engine on, right? And I said this is dynamic. Data's not changing. I'm not doing, all I'm doing is turning on the inference engine so it uses that rule. So I go ahead and save that now. I'm going to rerun that query, and I'm going to hit my limit because there's lots of people who have spent apparently lots of money with our fake e-commerce company here. But I went ahead and just used that concept. So it made my query a lot more simple. All customers who made large purchases. I actually also removed the hard-coded logic of what a large purchase is. So if I change my definition, I don't have to necessarily change this query. If I build a rule on top of this, I don't have to change the rule. That's really nice. I lack that hard coding that you often run into kind of more traditional approaches. I'll go back over to the designer, make some more rules. All right, I'm going to do a rule for big spender. Not make the same mistake I made last time. Let's create the concept ahead of time. And big spender. That is type of customer. And now we can go to our rules, and we can basically create that query that we just did. A big spender is a customer who made a large purchase. And that customer is a big spender. Probably a pretty reasonable classification for anyone who's dropping 10 grand on a single purchase. They are a big spender. Let's try and create more. We can have these kind of compound rules where I created one rule and then I'm using the inference in a subsequent rule. So rules can call rules, or you can have larger, more sophisticated rules. So I can say baby apartment shopper. This will look a little bit like our original query builder query. I'm going to say customer who made a purchase. That purchase was for a product in a category. Really, the only difference from query builder is designer is not linked to any particular database server or knowledge graph. There's nowhere really for me to look up the electronic category. So my rule is just slightly different. Let's say the category name is equal to baby. So customer purchases, and of course I forgot to create it. We'll just use the wrong thing here quickly. Back, baby apartment shopper. That 2 is a customer. You can see we're just expanding out. Some more concepts here. Get a 20 purchase in 2022. Another concept, specialization of a purchase. And then we can say analogously, people who bought things in 2022. And I forgot to connect it. No worries. Tweak our model at any time. There. I've got a couple of these kind of stub classes that represent the boundaries of my rules, or kind of what my rules are inferring. So I'm going to go ahead and baby department shopper. I've done the wrong thing. The right thing there. Now I'm going to go back and use that purchase whose date is between January, we want to do 22, right? January 1, 22 and December 31st. Purchases whose date falls in that range of 2022 purchases. And then let's do the last one. So we can say all of our customers made a purchase that was in 2022. That customer classified as people who bought things in 2022. So yeah, handful of rules here. big spenders, baby department shoppers, those sorts of things. Go ahead and republish all my stuff. Give my knowledge graph the latest and greatest. All right, that is all done. I'm just going to go back to here and refresh Explorer. Make sure I get the latest. Here's all my new concepts. Here, big spenders, people who bought things, customers. So I can go ahead and start using these. Say, I want to find all of the customers made a purchase. That purchase. I'm kind of referring back to the customer because I want to say some things about that customer. The baby department shopper, they're a big spender, and they bought stuff in 2022. There should be a handful of folks. So you can see they're kind of triply typed. Here's all of them. It's all easier to see them as a list. I can back to my query builder and expand graph results out again, and I'll see kind of the lineage for all of this, how it comes to be, how it all comes together. There we go. We can see their purchases and their products, and these are the large purchases. And if we dig in, we'll be able to find here's the purchase in 2022. So very quickly and easily, I was able to find very specific people in this data set. There's 5,000 generated people. This found 20 specific ones meeting a specific set of criteria. I did it without changing the data. I did it without massaging anything. I didn't set up new infrastructure. I didn't even consult anyone. I just started kind of putting together what was in my head in Designer and built the knowledge graph that represented my data in my world. And I think that's probably the most powerful thing about this technology is I can just kind of make it do what I need to fit my use case, and the flexibility is tremendous power in moving quickly. And I think you can see how this is a very iterative and agile process. I was adding properties and relationships on the fly as I remembered them. I was fixing rules as I was building them, adding new concepts that the rules were inferring as they were needed, letting the AI that's built into the Stardog platform handle some of the drudgery of mapping for me. Even some of the modeling aspects, we saw that with inferring the data model for addresses. Very quickly and easily built up, pretty cool knowledge graph for the amount of time that we put into this. And there's just more stuff we can do, more data sources, and build more interesting queries, build more cool rules. So I know we are coming up close to the end of time. I think we've got about 7 minutes left. So I just want to come back here and actually try and do some wrap up and turn over for questions for the last few minutes. There we go, slideshow. So things that knowledge graphs can do that we didn't talk about today. Data validation, I touched on it some. I talked about how it can be used to improve data quality, but we didn't get into the details of that. But I listed here because data quality is really important. Activating metadata with a knowledge catalog. I mentioned Stardog can talk to Calibra, Purview, Unity, all the places where you're keeping information about your data sources, so you don't have to go into that project resource dialog and add them one by one. We can find them for you and let you just pick them out of a group and immediately begin mapping and modeling. Using NLP, so a lot of data out there that's text, it's not structured, it's not in an RDBMS or other data system. So we support integration with best of breed NLP technologies to slurp in that unstructured data. Knowledge graphs work with everything that the enterprise already uses. If you like Jupyter, if you like Tableau, if you like just working in Python, all of these already work with Stardog and the knowledge graph approach, Sparkle, SQL, GraphQL, whatever you want to use, Stardog supports it. Training models using built-in machine learning. So Stardog's got statistical machine learning built in addition to the logical inference capabilities that we just saw. You get statistical and logical inference built into the platform, and then large-scale graph analytics powered by Spark. So if you've got a Spark cluster, you can do PageRank, click detection, connected components, any of your standard graph analytics. You can write your own graph programs, Scala, Java, whatever JVM language that'll run in Spark to do your own large-scale knowledge graph analytics. So just to recap what we talked about, we learned what knowledge graphs are, why they're so important, why they're central to success in the modern enterprise, why they're the heart of the modern data stack. We got to navigate a kind of fully baked customer 360 knowledge graph that had a variety of different sources that supported kind of a customer 360 use case around an e-commerce based scenario. And then we tried to rebuild that. And I think we did a pretty good job. We built a large portion of that knowledge graph. And in many ways, we extended it. The original didn't contain any rules. So you could actually go back in and create your own if you have better ideas for rules. So we got to create rules, we mapped data, those rules used, and we created the data model that powered all of it, put it all together. We did it all without writing a single line of code, without dropping to a command line or a terminal. This is all very easy, point and click interface. You can absolutely do this stuff at home. This is not hard. I think everyone can get started with knowledge graph quickly and easily. So I encourage everyone. I know I've gotten questions and tried to answer them throughout. We got about 8 minutes left. So please, if folks have other questions, shout them into the chat or shout them into QA. First question is, what is the general duration for an organization to adopt Stardog? What are the major steps? Okay. That's a great question. To do an entire talk on just that. We have a talk on that actually that we're helping with for later on this year that you may find helpful. But for now, I think the easiest way to get started with knowledge graphs, I mean, obviously go to Stardog and get started, but the technology is built through 20 plus years of data integration experience. Myself and the rest of the founding team, we spent 10 years building knowledge graphs before we built Stardog. So we understand what it takes to build a knowledge graph. And it was just 3 people. We knew how to do it quickly and efficiently. So the Stardog product experience is built around this iterative, based on SDLC principles notion. So you get started by picking one data source and making it a knowledge graph. And then you pick another that's related and you connect that to the knowledge graph and you work from there. Sprint by sprint, source by source. Do customers use pre-built ontologies or build their own? I have seen a mix. There are organizations who make the investment and have ontologists. They have them on staff. So they have teams who do data modeling. So that's absolutely an approach that it can work. But as you saw with Designer, I mean, you don't need a formal PhD to do data modeling. This is a very simple practice. So you can go ahead and just build yourself. I tend to encourage people to always start from a model they built themselves. There are a lot of really, really, really great data models out available on the web, and you should leverage them. They tend to be very large. They're difficult to get started with. If you put them in Stardog and you load them in Explorer, you're going to see a ton of stuff. And they're not built for getting started with knowledge graph. They're for much further down the maturity curve. Next up, how does the knowledge graph present the data to Tableau or to Python? So for Tableau, the knowledge graph just takes SQL. So Stardog has a SQL endpoint, so you send SQL to it. So from Tableau's point of view, we are a kind of quirky version of MySQL. So it's just SQL. Python, you can just send SQL, use any Python library that supports SQL, but we also have PyStardog, which is our implementation of Stardog's native APIs that'll let you work directly with Stardog from Python. Then you can take graph results, turn them into data frames, and then kind of go about your normal process in doing data science. Can you talk about the knowledge graph Stardog already built for financial services? So I won't claim that we built them. All of our customers built them, but they absolutely used our technology. We've been using the financial services space in a variety of different ways. The initial use cases were all around compliance, particularly reporting things to the federal government here in the States. It's obviously a very important situation to make sure your data is absolutely correct. It's absolutely up to date. The validity is not suspect. So these are really good fits for a knowledge graph. So we've seen that uptake. We've seen kind of fraud, anti-money laundering cases in banks, and even more mundane stuff like keeping the NOC running and the servers that power the business, kind of operational awareness, asset management in the IT space, something that isn't necessarily the sexiest topic, but if your ATM network's down, if the bank tellers can't access the back-end systems, you have some very unhappy customers. So that's another case where graphs are a really good fit, knowledge graphs in particular, because that data is always spread across many different places. All right, I don't see any more questions. We have got about 3 minutes left. So if people have other questions, I am more than happy to answer them. I also encourage everyone, again, cloud.stardog.com, go check it out and go use this yourself. The final product link is still in the chat, as is the link to GitHub for the raw training assets, those CSVs that we were using. I believe this has been recorded, so everyone can follow along after the fact. I know it was a whirlwind 90 minutes. We did and covered a lot. So go back through with Stardog and follow along, and you'll see how easy it is to build a knowledge graph with Stardog and get going with changing how you think about and use data. Want to complain or compliment me, you can yell at me on LinkedIn, and check us out at stardog.com. I'd like to thank everyone for their time. Oh, Q&A, thank you. So I appreciate everyone for coming, for all your attention today, and I hope you enjoyed the presentation.